Studying a single moon like Apotus might seem like a small step in space exploration. But what if that small step gave us insight into the entire architecture of alien solar systems? As our tools for detecting exoplanets improve, scientists are turning their attention not just to the planets themselves, but to the moons that orbit them. These alien moons, called exomoons, could outnumber planets by the thousands and may hold the same, if not greater, potential for habitability. What makes moons like Apotus especially valuable is how their extreme diversity challenges traditional models of planetary formation. Most early models assumed moons were relatively simple, formed from leftover material or captured by gravity. But Apotus, with its dual hemispheres, subsurface ocean, equatorial ridge, and vanishing effect, tells a different story. Moons can be just as complex, volatile, and diverse as planets themselves. If Apotus exists in our stellar neighborhood, what stranger moons might orbit distant gas giants in other star systems? Could some have atmospheres? Could they host alien oceans, tectonic activity, or even life? Exoplanet hunting missions like Kepler and TESS have already discovered thousands of exoplanets. But finding their moons is more difficult due to their smaller size and limited gravitational effects. However, new instruments such as the James Webb Space Telescope, JWST, and the upcoming Plato and LUVOIR missions may soon provide us with the precision needed to detect large exomoons and even analyze their compositions. Apotus serves as a model. By analyzing how it interacts with light, gravity, and its environment, we can calibrate our instruments to recognize similar anomalies in other star systems. The way Apotus vanishes from view due to albedo contrast could help us interpret similar dips in brightness from distant moons. Additionally, the presence of subsurface oceans on moons like Apotus opens up a revolutionary idea that life may not require a planet at all. A moon with internal heat, water, and organic materials could become a cradle of biology, especially if it's orbiting a stable gas giant within the habitable zone. Some scientists now suggest that exomoons may be more likely to support life than exoplanets due to their ability to retain heat from tidal forces and their potential for chemical cycling. If Apotus has taught us anything, it's that complexity doesn't require size. It requires the right conditions. What's more, moons might survive events that destroy planets. If a planet is scorched by its star or ejected from its orbit, its moons might linger in space, frozen time capsules of pre-catastrophe conditions. The these rogue moons could become vital to understanding long-lost planetary histories. Through the lens of Apotus, we begin to see moons not as accessories, but as key players in the cosmic game of habitability, evolution, and survival. In the next segment, we'll zoom out even further. How does Apotus and moons like it reshape humanity's quest for meaning in the universe? What does it say about our place among the stars? The journey is far from over. Stay with us.